Greetings and salutations, Ranting Engineer back at you. This episode goes along with the last one. I want to expand on understanding the bigger picture, but it's also understanding what is truly scientific principle and what is actually scientific calculations. Because a lot of people don't understand the difference, but they latch onto scientific calculations, and it can be very dangerous. So the example I'm using, there's a video out around on Facebook and in media right now. It's about climate change. Now, this video is not about climate change. I'll probably do one on climate change after this series is done. Anyways, the point is, this guy talks about the properties of carbon dioxide. And he shows that a specific property of absorbance reflectance, it's just a property of CO2. After a certain concentration, basically levels out. So the curve goes up, and as soon as it hits a certain concentration, it kind of levels off, which means at a certain point, you can keep increasing the concentration of CO2 and its property doesn't change. So if I use the absorbance of CO2 doesn't change after a certain concentration. Well, that's scientific principle. That's a physical property of CO2. Now, in the general scientific community, nobody argues it. Politicians can't argue it. It's like saying water boils at 100 degrees Celsius at sea level. Everybody knows it. It's proven. It's documented. Not a problem. Now, in the other part of this video, this guy goes on to say that humans only contribute some small amount. It's like 0.4% of CO2 is contributed by humans driving cars or something like that. I'm not going to go into the details. Then he goes on to talk about all these other larger contributing factors through CO2. He's kind of indicating that the CO2 is naturally occurring. One of the things he specifically cites is basically CO2 due to rotting vegetation. Now, you have to be very careful. When I look at this, I go, somebody's going to grab onto that number and say, a scientist said this number is 0.4%, so therefore it's true, it is rule, and everybody starts bitching and complaining and arguing and stuff. As a scientist, as an engineer, I look at it going, I don't necessarily believe that number's right. It might be accurate in the way that it was calculated, but it might be total bullshit in what the actual number is. And the reason for this is, I'll explain. And this is where you need to understand the difference and quit bowing to what could be calculation instead of science, because everybody buys into science too much, and it can be very dangerous. So my point is this. Somebody probably did an experiment to figure out how much CO2 is generated per, we'll say mass, volume, whatever, per unit of rotting vegetation. And some scientists got a hold of it and said, okay, let's assume that all rotting vegetation gives out this amount of CO2. Then I'm going to make an assumption that there's a certain amount of this rotting vegetation worldwide. So there's two assumptions there. One, is that number of how much rotting vegetation is accurate? It's an estimate. It could be calculated, but it's still an estimate. Then the other assumption is that all rotting vegetation puts out the same amount of CO2. So right then and there, you've got two potential errors in the calculation. What it would be better to say is, hey, we went through the calculation, we looked at the approximation and everything, and it's showing that the amount of CO2 that humans put in the atmosphere is quite significantly smaller than these other forms of CO2 that's coming in. So you need to look at it. You've gone from a CO2 property that's measured, that's known, that's not debatable, it's repeatable, it's documented, to somebody touting a number for an argument against climate change. Again, this isn't about climate change, it's about the methodology. Everybody in the public reads this and go, oh, wow, okay, is the number real? I, from a standpoint of a scientist and engineer, go, that isn't scientific principle. That is a calculation with assumptions, with a basis, that gets to a number that could be right. It might not be. I'm not arguing that the scientists or whoever it was that did the calculation tried to do the calculation as best they can. But when you start picking apart what is science like that and these numbers, you need to understand that these can become political talking points. They can be misconstrued for business. So what if they got the number off by 10? Okay, that the number was for the amount of vegetative CO2 minutes was off by 10. That means humans are more like 4% instead of 0.4%. what if they underestimated the amount of CO2 that's been put up by vegetation? That means the amount put out by humans is even less than 0.4%. So you need to understand the difference between scientific, physical, measurable principle and calculations. So when you see stuff in news, people touting, oh, I did this, the amount of CO2 that goes up because of this source is this amount, there's a lot of assumptions, there's a lot of fudge factors in that calculation. Again, I don't cite that people are trying to do it wrong, but they might have the wrong basis. They might have the wrong assumption. They might have missed something. Okay, so that's my rant about anybody that thinks about science needs to understand the difference, because I know the difference. I'm challenged this all the time. So again, when somebody throws something up on Facebook, a lot of the times I start looking at, how did you get to that conclusion? Show me your calculations, show me your basis. And a lot of times they're a bit wobbly, especially when you get into things like climate models. There's lots of good videos out there showing that there's different trends, there's different measurables, and there's lots of assumptions. So when people start throwing up numbers on it, you got to look at the basis, and you got to look at the factors they've used to do those calculations. All right, this is a bit of a long video, and thanks for holding up. All right, we'll talk to you later, and I will do my final video probably tomorrow. Have a good one. Bye.